In this video, I will show you the easy way how to solve the volume of solids of revolution. Find the volume generated when the area bounded by the curve y squares equals x minus 2, the x-axis, and the line x equals 6 at first quadrant is revolved about the x and y-axis. First, let's graph the area to be revolved. Locate the intersection of the curve and the line x equals 6. They intersect at point 6, 2, and here's our area at the first quadrant. Tip number 1. Use a strip perpendicular to the axis of revolution. For example, to solve the volume if this area is to be revolved at x-axis, we must use a vertical strip. Dimension will be y and dx. Tip number 2. Let's assume that the strip is revolved around the x-axis and it will make a circular disk. This disk will represent as the differential volume of the solid. Now, let's exaggerate the figure of the disk into a cylinder to help you understand the formula. The radius of the disk is the height y of the strip, and the altitude of the disk is thickness dx of the strip. From these figures, let's get the differential volume, that is dV equals to area of the base pi times y squared, times height dx. Integrate both sides, and we get the formula of volume equals to pi integral of y squared dx from x1 to x2. Now, solve the value of y in terms of x to proceed to integration. As you can see, the height y is equals to the y of parabola. In the formula, we need the value of y squared, and from the equation of the curve we already have that value. So substitute y squared equals to x minus 2. And the limits should be from 2 to 6. And the volume is equals to 8 pi cubic units. Now let's solve the volume if this area is to be revolved about the y-axis. If the axis of revolution is through y, we must use a perpendicular strip which is in horizontal. Assume and draw that the strip is revolved about the y-axis. As you can see, the area to be revolved is not adjacent to the axis of revolution, so we expect to get a disk with hole at the center. To get the differential volume of this one, we need these dimensions. The length of the strip is x, height is dy, the inner radius is equals to the x of the parabola, and the outer radius is x of the line. Refer to our drawing. The differential volume is equals to pi times the quantity of the difference of the squares of the radii times height dy. Again, from the given line is x equals 6, the curve is y squared equals x minus 2. Therefore, the x of the parabola is y squared plus 2, and x of the line is 6. Now, integrate both sides, and we get formula of the volume equals to pi integral of quantity of 6 squared minus square of y squared plus 2 dy. Limits is from 0 to 2. And the volume if revolved about y-axis is 46.93 pi cubic units.